Hi everybody, welcome to section 8.4, which is the section on the confidence interval for the proportion. So in this section we've got a new statistic parameter pair. So just like we had the sample mean as the statistic, the best point estimate for the population mean, just like the sample standard deviation is the point estimate for the population standard deviation. Now we have the sample proportion, which has the symbol P bar as the best estimate for the population proportion P. P bar is calculated as the number of successes, which is not a value judgment, but just whatever the thing is you're counting in the sample, and N is the sample size. P hat is calculated as X, P bar. Some textbooks call it P hat. P bar is calculated as X over N, where X is the thing you're counting and N is your sample size. So let's just say, for example, in a sample of 300 people, 230 of them plan to take the coronavirus vaccine. So that would be X, which is 230, the thing we're counting in our sample, divided by 300, our sample size, which comes out to be 0.7667. As you can see, if you look here, equals 230 over 300, so 0.7667. Proportions have to be between 0 and 1. Any proportion outside of that is not a valid proportion. You may be asked, this may be phrased differently. It may say in a sample of 300 people, 76.67% plan to take the coronavirus vaccine, and you would need to find this 230 by just doing 76.67% times 300. So to do a confidence interval, we need this formula. We know what P bar is. We know what N is. And this Z is exactly the same Z we've been seeing. All right, so this is the same Z that was from the first confidence interval section we covered. This part, and by the way, this formula comes from, there is a sampling distribution for the proportion. And just like we set up the formula using the sample mean, the sampling distribution for the sample mean, to come up with the formula for the confidence interval for the mean, that's exactly where this formula comes from. Okay, but that was a section I didn't make you cover because most students hate probability, and the only reason to cover it was just to show you where this formula comes from. So, to get this in Excel, we are going to create something called a template. And a template, because you may notice in this problem in particular, it can be easy to make a mistake in here. It can be tricky with the parentheses to get the order of operations right, because you need to make sure this whole thing gets underneath the radical. So we're gonna do it once, and we're gonna set it up where all you have to do is change some numbers at the top every time, and it'll automatically do it from there. All right. So, and I want to tell you, this is a really efficient way to work. It'll help your efficiency. It also keeps you from making so many mistakes, both of which are good things for an employer. They tend to like when you do things fast and without mistakes. So we're going to make this template. We're going to make it together. And I don't mind if you use the template on homework, on tests, but the thing is you have to make it yourself. I'm not going to make it and post it for you to use. So that's for you to do, for you to follow along with. All right, so we are going to set it up where I think of it as being the user, whoever's using the template, which in this case is just going to be you, is going to input your X, your N, and your confidence level. And we're going to need to input those, and then it's going to give you everything you need from there. All right, so X in this problem is 230, or you may need to calculate that based on 76.67% of 300. Make sure you round that, though. You want that to be the nearest whole number. N is 300. And in our problem, we want 90%. So this is our first problem. So the first thing we want our template to do is calculate the sample proportion. So the sample proportion is just going to be X out of N. Right? Now, if you remember, we need to find Z now. If you remember when we did this before, we did norm.s.inv, and we need the tail probability. So that's going to be 1 minus our confidence level. And on all of these, we have to refer directly to the cells. If we type this in as 0.9, the template is not going to work because we want it to be able to update when we just change these 3 cells up here. So if we do norm.s.inv, this will give us the tail area. We're going to need to type in the negative here because if we don't, this is just a negative sign, so we want to make it not negative, so we'll put a negative at the beginning after the equals. All right, so that's our value of Z. So now let's come up with our margin of error. So our margin of error, the part after the plus or minus, is going to be Z times square root of. And this is where we have to be really careful with the order of operations. So what's on the top, let's put inside these parentheses. That's going to be P times, oops, not P. We're going to refer to this cell, the sample proportion. This is getting a little bit confusing. Let me go back. Let's start again here. So Z times square root, and we need the top part of the fraction. And so let's put the whole top part of the fraction in parentheses. So P bar, times 1 minus P bar. So we'll close this parentheses. Now we need to close the one that separates the numerator from the denominator. And now we need to divide by the sample size. And now if we close that parentheses, then we've closed the square root. And that tells us that we've got all of this under the radical. Right? So this is our margin of error, 0.0402. And you may be asked to state your confidence interval in margin of error form. So that would be 0.7667 plus or minus 0.0402. You may also be asked to state the lower confidence limit and the upper confidence limit. So your lower confidence limit is going to be your sample proportion minus your margin of error, and then your upper confidence limit is going to be your sample proportion plus your margin of error. All right, so we've got our first answer. So if you're asked to state it in margin of error form, it's going to be 0.7667 plus or minus and that was 0.0402. And then in interval form, and we need to include an interpretation here, we are 90% confident the population proportion of all people, or the proportion of all people who plan to take the coronavirus vaccine, is between 72.65% or 0.7265 and 0.8068. All right, and you always need to include that interpretation. And this is just a sentence, honestly, you can just copy, change the context of the problem and change the numbers. Okay, and by the way, I just made up this data. I don't know if the proportion is that high. I hope it is. So now that we've got our template, the next problem is going to be super easy. So in this problem, we have a sample of 150 customers who purchased a tire, and we know that 42% also purchased a warranty. And we want a 99% confidence interval. So here, we've got 150 customers who purchased a tire, and we know that 42% of those, so 0.42 times 150, also purchased the warranty. And now if we change our confidence level to 0.99, that is all we have to do is change those three numbers, and we don't have to do any more computations because Excel is doing it for us. So our answer here in margin of error form is 0.42 plus or minus the margin of error, which is 0.1038. And so we are 99% confident that the proportion of all customers who buy the warranty is between 0.3162 and 0.5238. They may ask us, based on this interval, does it seem reasonable think that half of all customers buy the warranty? And the answer here is, if you look in your interval, 50%, half, 0.5 is in that interval. Therefore, that's a plausible value for the population proportion. So you would say yes, because 0.5 is inside the interval. All right, so that's all you have to do on those problems. This is, I think, a pretty easy section. Before we leave it, though, I want to mention, how do you identify a problem as a confidence interval for a proportion? So when you read a problem, how do you know it's this kind of confidence interval and not one of the other ones we've done? Well, to start with, a lot of times it'll just flat out use the word proportion or percent. Just keep in mind that that's not for the percent confidence. But so you might see the word proportion, but always, always your data can be rephrased as X out of N. So 42% out of 150. Or 230 out of 300, or 3 out of 4 dentists recommend Trident or something. Okay, so that's how you know. All right, so that's it for this section, and I hope you'll let me know if you have any questions.